This video is based on a recording of a live event. It contains additional content to help the audience understand the context of the topic presented. If you wish to skip directly to the primary topic, see the timestamps in the video description.
So Andrea Kropp, Senior Data Scientist at DataRobot. Today we're going to be talking about a technique to improve model accuracy. Now, when you're talking about model accuracy, it's always a time accuracy trade-off, right? If you had 3 years to continue to work on the same model, it would continue to get more accurate. But what we're going to talk about today is using some of DataRobot's advanced automation features to really allow you to achieve that kind of end goal accuracy without having to invest more time. So let's go ahead and get started. We'll spend probably about 2-3 minutes looking at some slides, and then we'll get directly over into GitHub and take a look at the notebook and exactly the workflow. So quick definition from Wikipedia on what is panel data. So panel data is a subset of longitudinal data where you have observations for the same subject over time. So you might think that panel data is only for econometrics. At least that's what you get when you search for it on Amazon. But panel data is more than just for econometrics. Here are some very simple examples where we have exam scores for the same student over time. This would be relevant in education. Here we have weather for the same city over time. This might be relevant in local government. But today we're going to be talking about flight delays and airlines. And I chose this example because it should be familiar to most viewers. And you may also be curious on what we can learn through a machine learning model about what causes flight delays. So today we're going to be doing a classification project, and we're going to try to predict this column right here. The takeoff is delayed by more than 30 minutes. In the data file we'll be using today, which is on our public S3 bucket, you can also run this as a regression project by selecting this other target, which is the delay in minutes. So we're going to have a couple different options for paneling this data. Again, panel data is where you have observations for the same entity over time. And here we have a couple different options. So we have the carrier code. We've got United Airlines and Alaska Airlines. So we could panel the data based on the carrier. We've got some origin airports. I live on the West Coast, so we've got a lot of San Francisco, Seattle, Portland's in here. So we could panel based on the origin airport, or we could panel based on the destination airport. And so in this example, we'll actually be using all 3 of those. So it's a little bit of panel data on steroids. All right. So at the outset, I said that this was about improving model accuracy. So I want to share kind of what is the key nuggets, like where is that additional accuracy actually coming from? And it's from this very extensive time-aware feature engineering. So if you zoom in and look at what I have on the screen here, these are different aggregated features based on the carrier, right? United, Alaska, so on and so forth. Different aggregations based on the origin airport and different aggregations based on the destination. Now, you could hand code all of these features, but you're going to wind up throwing most of them away as not useful. So in that whole balance between model accuracy and the data scientist's time, this is where we really want to use automation to automatically generate all these features for us. And then move into the modeling step. So that's really the nugget of how this self-join technique works. If you've been in the DataRobot graphical user interface, there's a place where you join the data sets. And the reason this technique is called self-join is because we're really only working with one data set. So this primary data set is that snapshot you saw in Excel. And we're going to join it back onto itself. So it looks like there's 5 data sets involved, but it's really only one. It's the primary data set joined back onto itself. So just to zoom in a little bit so you can see what's happening here. In our primary data set, we have those different columns that we saw in the spreadsheet. And for the origin airport, we're going to join the data back onto itself. And we're going to hypothesize that, say, What's going on at the origin airport in the last 3 days might be helpful for our prediction, and also what's going on at the origin airport in the last 10 days might be helpful for our prediction. So this is where you can insert some subject matter expertise to kind of control the types of aggregations that you're going to get. Very important with this setup, and I will try to refer to it a few times, is avoiding what's called target leakage or future leakage. So if we look carefully at the data set again, I grabbed a snapshot here somewhere between that has some rows from January 14th and some rows from January 15th. If it was today, January 16th, right, we would only want to use information from the past to try to predict flight delays for today. So it's going to be very important that we don't include information that we don't actually know on the 16th when making those predictions. And if you look carefully at the data we have available, these columns on the right-hand side are actually subsets of what's causing the overall delay. And so these things are actually not known at the time of prediction. So we're going to scoot over to the notebook. You'll hear me refer to this kind of preventing target leakage quite frequently. And you'll also see very clear descriptions of that in the notebook. All right, now we are in GitHub. Specifically, we are in the DataRobot Community AI Accelerators GitHub. And the notebook we're looking at here sits inside Advanced Experimentation and is called Self-Joins. We're going to spend the bulk of our remaining time together looking through this notebook, but I did want to call out the fact that this notebook can be directly imported into DataRobot notebooks. If you ask for this notebook as a raw JSON file, you'll get something that looks like this. And if you copy this header, you can come over to DataRobot notebooks. You can upload a notebook from a URL. Go ahead and paste that in that we just grabbed from GitHub, and that's going to import that notebook directly into DataRobot notebooks, and you can run it from here. So because this does take some time to run, we will look at the completed one in GitHub. Just wanted to demonstrate the tight integration between the AI accelerators that exist in GitHub and the new DataRobot notebooks. All right. So let's go ahead and go full screen on this tab, and we'll take a look at it. All right. So this notebook is an end-to-end solution of this use case. It includes the starting data and everything you would need to replicate it, assuming that you have access to DataRobot. So there's some contextual information about when to use self-joins. There's some information about what the notebook contains. As I mentioned before, there's a lot of cautions about avoiding target leakage. There's some information about where this data originally came from. This is actually real data from the Bureau of Transportation Statistics. And then we get into actually working through our use case. So this should be very familiar to anyone who works in Python regularly. You've got, pandas, NumPy. The only thing that will be new will be importing the DataRobot package as DR. There's a variety of different ways to connect to DataRobot. You can click this link to understand what all of your options are. And then here we're going to grab the data from our public S3 bucket. You can just right-click this link and it'll download as a CSV file to your local machine, so you can take a look at it. The beginning setup here really is a lot of exploratory data analysis, which is always interesting to know exactly what you're looking at, but isn't really the main teaching point for today. So we will go ahead and scroll past some of that. I'll pause here briefly so you get a sense of kind of the distributions of the data. Most importantly, here in the lower left, this is the target that we're going to be predicting. And about 1/3 of our flights are delayed by 30 minutes or more. All right. Now we get into a section of exploring a little bit more about the panel features that we're going to use for the self-join technique. So we're intending to join on the origin airport as well as the carrier code. so we can see kind of what percent delayed our target is. And we're also going to be self-joining on the destination airport. I would have thought Anchorage would be more delayed than Albuquerque, but hey, that's why we do these projects. All right, so I definitely skipped through all the exploratory data analysis. That's not the teaching point for today. Today, we're talking about self-joins. So we are going to self-join the same data set 4 times. And when we do that, we are going to need to keep careful track of this target leakage. So we're going to wind up using 2 different feature lists. When we join the data sets together, we're going to want to have this gap so that we're only aggregating on things from yesterday or the day before. We don't want to aggregate on flights that happened on the same day or in the future. So to do that, we will carefully create these feature lists based on subject matter expertise of what are the things that we would have known at the time. At that point, we can check that all of our new feature lists exist, and we'll be able to start a project. So if you are unfamiliar with DataRobot, this is basically starting a model competition. I did actually start that competition about an hour ago, so I'm going to switch over and just briefly let you see it running in the graphical user interface, and then we'll come back into this code first experience. So this is my June 8th run. I did actually execute this from a DataRobot notebook, and it is running here in the graphical user interface. So we are now running a model competition across many different techniques. There are additional kind of competition entrants running over here on the right-hand side in different containers. And as each of these experiments complete, they'll be added to the leaderboard. This is also where we can see some of those features that have been created that I had in the slides at the beginning. So all of these feature aggregations have been created after we kicked off that self-join process. So it looks like this one is one of the more important ones, and we can take a look at the feature lineage of how all of those different tables came together. So today's audience is that code first user, so we will spend the rest of the time in the notebook. Just know that you can collaborate with people who prefer to work in the graphical user interface. Everything you're executing here in the notebook is also reflected in the GUI, so you can share it with coworkers or managers very easily. All right, so here we're going to need to define our self-join rules. No surprise that there are 4 separate definitions happening here. So we need to define what is the unique identifier and what is the name of the date time feature to be able to link our data sets together. So we'll do that using dataset definition, and then we'll establish the relationships with the function you see down below. So what you're looking at here corresponds to that one picture that I zoomed in at the beginning. And this is where we're inserting our hypotheses about how far back do we want to look in the carrier table or in the origin join or in the destination join. So we can support up to 3 different look back periods here. Mine just has 2, and this is where you would want to maybe consult with some of the airline operations staff to ask them what they think is relevant as a look back period. It's worth noting that this one is a little bit different than the others because we're joining on the origin and the carrier. So if you think about your nearest airport, it might be that there's something strange happening at that airport, or that that carrier at that airport might be experiencing some staff shortages. So it is certainly possible that it's something about the carrier-airport combination that is not common to the carrier at other airports or is not common to the airport in general. And so that's why you're seeing this join based on the origin and the carrier. All right, most of the rest of what we're going to see here is going to appear in sets of 4. So we have 4 data definitions, we have 4 relationships, And at that point, we can tell DataRobot what sorts of aggregations we want to perform. So do we want the mean, the median, the kurtosis, how many missing records there are? So you can query what are all of the feature discovery settings, and then you can set these to true, false manually, or you can just default them all to true. All right, so here is the bringing it all together. So everything up above was defining a lot of the settings, and now we're going to bring it all together in this relationship config. So we've got the data set definitions, the relationships, and the feature discovery settings. And once you do that, you can switch over to the graphical user interface, and you would get a relationship diagram that looks just like this one. So that is essentially the end of the technique, because now we are ready to start the project. So once we execute this cell, we will actually tell DataRobot, this is our classification target. We want to optimize based on log lost. We have that entire set of relationships that have been defined up above. We want to use all of the workers available to us. And this one does run probably about 4 to 5 hours with 20 workers, which I have access to. So if you do replicate this project, be prepared for it to time out on you, even if you set the timeout fairly high. So because we did do this in advance, we can now take a look at the features that were created. DataRobot does do feature engineering and reduction, so it will throw away features that are not at all related to your target. We wound up with 731 new features, and here's just a random selection of 20 of those. So again, going back to the beginning, this is really about a time accuracy trade-off. Again, if your manager gave you the same project to work on for 3 years, you would continue to make progress on the accuracy. But you may not even have thought of all of these different aggregations, let alone want to hand code them all. So what we're demonstrating here is using automation to generate all of these time-aware features and then be able to pass them directly into our binary classification project. The rest of this notebook is going to be common to any other use case that you're doing with DataRobot. You can retrieve all of the models. The top performing model here happens to be an XGBoost variation. You can request the log loss and the AUC for that model. You can compare it to other models as reference projects to make sure that you're actually improving accuracy over time. And then, of course, you want to understand what your top model actually learned. So we just scrolled past all of the different experiments, and now we're just looking at the top experiment. So we're looking at that top performing XGBoost algorithm, and we're looking at which features are actually included. So we saw previously that there were 731 features that were created. This model is actually using 720 of those. So there's also going to be a complexity versus accuracy trade-off. We show a couple examples here of how you might trim this down to just the features that contribute 1% or more. There's 91 of those. That feels better to me than 720 features in my model, but you would want to compare how that feature reduction impacts your log loss or your AUC. Lastly, just wanted to include in here kind of when DataRobot creates these aggregated features based on your panel data, it will assign what we think is a pretty good human readable name. And I did also show you how you can go in and look at the feature lineage visually to understand where that feature came from, but just wanted to provide a few examples of what these auto-generated names actually mean. So that is the conclusion of my notebook walkthrough. I am certainly available for questions. I am not an airline expert, but I definitely had fun putting together this demonstration for you. And I hope that it allows you to improve your model accuracy without having to invest a lot of extra data science time. Thanks so much and have a great evening.